Okay, Assalamualaikum warahmatullahi wabarakatuh. Hi class, so let's go through some examples on the half-wave rectifier. So we have two examples here. Okay, example number 1, where you are going to have half-wave rectifier. So the half-wave rectifier consists of 2 kilo ohm load, and you are given VRMS, means this one is what input of the transformer is V primary, right? So the primary given here is 120 volt VRMS, and it contained as 60 Hz power supply. Your turn-in ratio here is 10 to 1, and your V gamma here is 0.7 volt. So what you need to find here is V out and ID and the fraction. Okay, question number 1. Okay, so in the question it given the value of VRMS. So what is the relation between RMS and V peak? VRMS equal V peak divided by square root 2. Step number 1, if the question given the value of VRMS, so always change your VRMS to V peak, the peak value. Okay, so now the primary value given, so this one V primary RMS is equal to 120 volt. So how are you going to change to V primary peak is equal V primary RMS so V primary RMS multiplied by square root 2. So you can get here is 120 multiplied by square root 2 volt. So this will be step number 1. Okay, so just now you can get number 1, V primary peak is equal to 120 square root 2. So how are you going to change this one to, how are you going to find V secondary peak? V secondary peak. So you need to use this formula. Vp over Vs equal N1 divided by N2. So what is your Vp? 120 square root 2 divided by your secondary, you don't know, right? Secondary peak equal, the ratio here given here is 10 divided by 1. So how you can calculate your V secondary peak is actually 120 square root 2 divided by 10. So you can get 12 square root 2 volt V secondary peak. Okay, after you got this V secondary peak, so what you need to do next is to find V out. So this one you already get the value 12 square root 2. So apply the KVL equation. So you become here minus Vs, always have the peak value, plus. So given in this question V gamma is 0.7. So you're going to replace this with V gamma, right? Because it's PLM1, V gamma plus V out, the voltage drop across resistor equal to 0. So you can get your V out, again peak value here is actually Vs peak minus V gamma, that is 12 square root 2 minus 0.7, and then you can get around 11 point. So you can get is 16.27 volt. So this is the answer for number 1. Okay, for question number 2, determine the peak diode current. So how you can get the diode current? You know your V out is actually ID times R, right? ID peak. So how you can get the peak current is actually V out peak divided by R. So you can get here 16.27 divided by how much is the value of the resistor is 2 kilo ohm. So the answer is 8.13 milliampere. So you are done with question number 2. Okay, so let's move to question number 3. Determine the duty cycle, right? The fraction of the conduction of the angle when the diode is conducting. So let's redraw the output graph. So here we when diode on, diode off, no output, and diode on again. So where is the fraction of the duty cycle? So here will be theta 1 here will be theta 1, here will be theta 2. So how you can get theta 1? Okay, you know when the diode start to on, what is the minimum voltage is 0.7. So 0.7 equal to your Vs. So your Vs here is actually just now, the peak is 12 square root 2 sine theta 1. So how you can get theta 1 is equal sine inverse 0.7 divided by 12 square root 2. So you can get here 2.36 degree. Okay. How you can get theta 2 is equal to 180 minus 2.36, around 177 degree. And then how you can get duty cycle is actually theta 2 minus theta 1 divided by 360, the whole degree multiplied by 100%. So 177 minus 2.36 divided by 360 times 100%, you can get around 48.6% duty cycle. So what does this mean? Means that almost half of the cycle will be on, the other half will be off. Means only 48% will be on, the rest will be off. So this is what that mean by duty cycle. Okay, so let's go through the second question. This is a simple half-wave battery charger. So you have what the additional element here is a DC supply here. Is given here 6 volt R120 and your input here is 18.6. Determine the peak diode current. Okay, so the first step that you need to do is you need to do KVL here. Okay, so what will be the KVL in this equation? Again, starting from here, always mention here V as peak because this is chapter 3, right? Plus R I D peak plus, so let's say what is the question given here? You're given here V gamma is equal to 0.64. So here is 0.64 plus your VB equal to 0. So you already know here is 18.6. Your R is actually 120 and your VB is 6. So you can calculate your ID to be 18.6 minus 0.6 minus 6 divided by 120, and you can get here 100 milliampere. Okay, so this will be the first part. The second part is the maximum reverse bias voltage. So this one, maximum reverse diode, means this is PIV. So remember step number 1, you need to make sure reverse bias. Step number 2, diode is off. And then you label PIV and then you put the sign. Step number 3, KVL. Okay, so first step, always mention here, reverse bias means here must be minus and plus. And then the diode will be off. So when the diode is off, here will be open circuit. And here you can name it as VR or PIV, any value. Okay. So next step, you do the KVL. Okay, let's see the KVL starting from here. Means here is V as peak. Okay, always denote the peak. Plus R, let's say you have I. Minus VR or PIV. Plus VB equal to 0. Okay, please take note this is open circuit, so you don't have any voltage drop here. So what is your reverse bias voltage here is actually V as peak plus VB. So this is what you can get here, 224.6 volt. Okay, continue from the previous question. Part C asks about duty cycle. So when talking about duty cycle, so you need to know what is the minimum voltage you need to turn on. So please take note here, there is a source available here, the DC source. So the minimum voltage to turn on the diode is not 0.6, it's not only V gamma because you have a source here. So here will be 6 volt. So you need at least here your VB plus V gamma in order for the diode to turn on. So what is the value here is actually VB plus V gamma. The minimum voltage to turn on is not only V gamma, because you have a power supply here. That is VB plus V gamma. That is 6.6 volt. Okay, so let's go through the equation of your duty cycle. So this is your wave, and then you have your theta 1 and theta 2. So for theta 1, so 6.6 is the minimum voltage. What is your input voltage here is 18.6 sine theta 1. So your theta 1 is actually sine inverse 6.6 divided by 18.6. So this is what you can get here, 20.73. Once you got theta 1, you can find your theta 2. Theta 2 is actually 180 minus theta 1. So this is what we got here. And then you just use this formula to get your duty cycle. So what does my 38.453 is only 38.453%. The diode will be on, the rest will be off. So this is what does that mean by duty cycle. Okay, so this will be the last example for half-wave rectifier. So please make sure you try to solve it by yourself, and let me know if you have any question to ask. Okay, so with that we end the half-wave rectifier examples. Assalamualaikum warahmatullahi wabarakatuh. Thank you, guys.